Let's look at this example that we did in class and just try to see all the details. First, we want to evaluate this integral over here. And this is the main part of the calculation. And we realize that we have two piecewise functions. If you look at v naught of s, it's piecewise. In fact, we know if you try to graph it as a function of s, this is what we have. If s is greater than or equal to 0, we get s. So this is 45 degrees, and this is s over here. And this is a graph of this function. Let me use a different color. So this is a graph of the function. Over here, 0, and this one. So in fact, you can see that v of 0 of s is the following piecewise function. It's s if s is greater than or equal to 0, and it's going to be 0 if s is less than 0. So this is piecewise. And if you look at f of x, it's also piecewise. We can see that f of x over here, if you look at it's a graph, this is x, and this is f of x. And between negative 1/3 and 2/3, it's 1. So here is 1. Okay, and it's piecewise. Now, why this f of x is a density function? F of x is a density function, we know. We only need to verify two things on the density function over here. Number one, f of x is bigger than or equal to 0. Surely it is true, right? Second, when you integrate the function from negative infinity to positive infinity, and this should be equal to 1, and we can easily check that's because this area over here is 1, and so that means it's a density function. So now let's look at how we're going to integrate this one. First of all, we see the following thing, that because f of x is 1 only between negative 1/3 and 2/3, so this improper integral v of s plus x, f of x, is really just from negative 1/3 to positive 2/3 and v naught s plus x and times 1 and dx. Okay, so now we need to just evaluate this integral over here. And how do we do that? We're going to try to do it, just look at the graph. We need to look at the graph of this function v naught s plus x versus x over here, because in this integral over here we can see that x is the dummy variable, right? X is the variable over here, and s over here is just a parameter over here. It's just a parameter, right? So when we integrate this function, we should look at its graph, and the horizontal line over here is going to be x, and this is v naught of s plus x. Now, we know what v naught of s is, so how can we get v naught of s plus x? Well, this is composition, so we have the following. It's going to be s plus x bigger than or equal to, it should be s plus x or 0, and here this is when s plus x is bigger than or equal to 0, and this is going to be when s of x is less than 0. That's just composition. We replace s over here, 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 to change that one to s plus x. So that's what we have. And then if we try to graph this function in terms of x, then we have the following. Using x as a variable, this is going to be x plus s. We switch the position, so we know this is variable, this is constant, and 0. And this is when x is bigger than or equal to negative s. We subtract s both sides. And this is when x is less than negative x. And that's where this negative s is from. So if you look at this function over here, it's piecewise, and the dividing point over here is negative s. We don't know where negative s is, So we can just say, maybe over here, this is negative s over here. Okay, and then the function we have, the graph looks like this. The graph less than negative s, it's going to be 0. Okay, and after this one, it's x plus s. You see the slope is 1, and when x is negative s, it's just 0. So we have again a continuous function, but it's piecewise. Okay, so this is the graph of v naught of s plus x. Now we want to integrate this function between, say, negative 1/3 and 2/3. That means we are trying to find this area. We are going to try to find this area over here. Right? That's the meaning of this definite integral. But if you look at it, this graph over here isn't really untypical because we don't know where this negative s is. This parameter s can change, right? So really we have 3 cases. This is just case 1. So why we don't just finish this case? So we say if we have negative s is inside this interval, negative 1/3 and 2/3. What it means is that negative s is greater than negative 1/3 and negative s is less than 2/3. If you multiply negative sign both sides, we know you switch the inequality. So this one over here means s is less than 1/3, and over here means s is going to be greater than negative 2/3. So really here means s is between negative 2/3 and 1/3. So in this interval, when this one is over here, then we have a triangle. So this integral over here is a triangle. So this integral over here from negative 1/3 to 2/3, because it's a triangle, so we can use the area. So here we use base times height, and because it's 45 degrees, we know height is the same as the base. So we just write down this v naught s plus x dx. This is going to be the area of the triangle. So we have 1/2 times the base and times height. And if you try to see what the base is, use the right end point minus the left end point. We have 2/3 minus negative s. And the same thing for the height, so it's going to be 2/3 plus s, right? So this is what we have. We have the 1/2 s plus 2/3 and squared. So that's what we have. Okay, and that's the area. Now we said this is not all. We have also other cases. So there is another case over here. It's possible our negative s is actually over here. You may say, how is that possible? That's when little s is negative, right? Negative s is over here. And your 2/3 is over here, and negative 1/3 is over here. And then if you look at the graph, your graph looks like this. 0 up to negative s, and then you have 45 degrees. So if you integrate this function over this interval over here, it's completely 0. So this one over here, you can say, when negative s is greater than 2/3, then we have this integral over here, negative 1/3 to 2/3, and this v naught s plus x dx is completely 0. So this is another case. So we have over here case 1, we have case 1 and case 2, and then we have our last case. So if you look at the last case, we have this situation because it depends where this negative s is. So now negative s is outside negative 1/3 and over here 2/3, right? And your function is still the same. It breaks at negative s, then 45 degrees, right? And your integral lower limit is over here and upper limit is over here. So this is going to be your area. And this is the area of the trapezoid. So from negative 1/3 to positive 2/3, V naught s plus x dx. In this case, is the area of the trapezoid. And area of the trapezoid we can easily find, and that's just going to be 1/2. We know this is going to be 1/2. We have height 1, that's the h1 plus h2 over here, and multiplied by the length, by the base. Okay, so the average. So what do we have now? If you look at the function, this function over here, we know this one over here is x, right? And this is x plus s. So we can find height over here by using the values. So what we have over here is x is negative 1/3, so s minus 1/3. That's the value over here. And then plus value at this other point is going to be s plus 2/3. Okay, so that's, and then multiplied by base. Base is exactly 1, so that's the area. And then we end up with over here 1/2 and 2s plus 1/3, and that gives us s plus 1/6. And this is the case when negative s is less than negative 1/3. That means s is greater than 1/3. So now we have this integral over here, negative 1/3 and 2/3. This integral v naught s plus x dx is piecewise if you think about it, and it's going to be s plus 1/6 if s is greater than 1/3. And in the middle, this is 1/2. Let's go back a little bit, and that's 1/2 s plus 2/3 squared, and that's when s is less than equal to 1/3 and bigger than or equal to negative 2/3. That's what we found over here. That's what we have. And if s is less than negative 2/3, then we have completely 0. So now let's graph this function. Graph this piecewise function. This piecewise function. And to do very carefully. So let's do that. We have 3 pieces, and we're going to draw a rough graph over here. So we have dividing points at negative 2/3, and here we have 1/3, right? So it's easy to graph the first piece. If s is less than negative 2/3, it's going to be 0. So we're going to have 0 over here. Okay, and if s is greater than 1/3, we have a straight line. Look at this one. We have slope is 1, and also when s is 1/3, we have 1/3 plus 1/6 is going to be 1/2. So we have somewhere over here 1/2. Okay, and the value over here is straight, 45 degrees straight. Okay, so this is s plus 1/6. So what's in between? We have this quadratic function. It's a parabola. But if you look at the value, if s is negative 2/3, the value over here is 0. So if you look at s is 1/3, the value for the middle one is exactly 1/2. So what do we have over here? In fact, is a parabola that actually connects these 2 straight pieces. Okay, so this is the second part of the function. And then we need to look at the entire function. We know that the entire function is the maximum of s. So we know v1 of s is the maximum of s, and this function above. So this above function over here. Okay. And we can actually find it just in the graph. What we need to do is just sketch this one. We need to sketch the graph of S. The graph of S is it's a diagonal. So what do we have over here? But just to be very careful, because this is going to be really, really close. This one over here is S. We know it's beneath this blue line because S is less than S plus 1/6. And the entire thing over here is beneath that. And then you have this one over here. So if you look at which function is bigger, and of course the function on top, the blue one is bigger. So what we have over here is simply this function on the top. That's let's call this function W0. How is that? W0 of S, which is equal to from negative infinity to positive infinity, and this is V0 S plus X f of x dx. So the second function is bigger than the first one, so we simply have W0 of S. This is done, but this isn't really a typical graph, because sometimes we actually see the first line, the straight line S, intersects with the second one. Then we take the top one, the bigger function, and then we will have again a piecewise function. But this one over here we are done. So this V1 of S is equal to 0 if S is less than negative 2/3, and it's 1/2 S plus 2/3 squared if S is between 1/3 and negative 2/3. Okay. It's a continuous function, so we don't need to worry about endpoints. And this is going to be S plus 1/6, and that's when S is bigger than or equal to 1/3. Think about the meaning of this one. It should be clear why we have V1 of S is equal to 0 when S is less than negative 2/3. And that is all.